Okay, so this is question number 8. So we have a survey that was taken of 150 residents in a small resort town to determine the attitudes towards building a hotel development. The occupations of the residents are determined along with their whether they approved of the hotel being built. Okay, so we're having one random person selected at random for this. Find the probability that the person is a businessman or approves of the hotel being built. This or will come in handy later on, but we'll come back to that. Okay, so we have a person, a businessman, right? We have businessman right here, in this category, and then approves with this category. Okay, so first we're going to calculate the probability of selecting a businessman. With a total of 150 people, as mentioned, there are 60 total businessmen. So we're going to use those two in this problem because we're going to find P for the businessmen, probability for businessmen. I'm going to abbreviate by writing P and B for businessmen. We're going to have the total number of businessmen, which is 60 right here, divided by the total of people, which is right there, 150. So we do 60 divided by 150. Okay, so we're just trying to find the probability of a businessman. And that comes out to 0.4. Right? Okay. So now that we have businessmen, it's also asking about being the approving of the hotel. So we have approve right there, right? And we have a total of 85 people that approved of the 150. So now we drop down here again. And then we're going to abbreviate A for approved. Same thing we did above. Total 185 and then of the 150. Okay, so 85 people approved of 150. And that comes out to roughly, we're just going to estimate right around that. Okay. But now we need to find the probability that the person is a businessman approving the hotel. So we go down to approve, and we find businessman, which is right there. Okay, so approved and businessman is 40, right? And again, of the 150. So we gotta do businessman. I'm gonna do /approved because it's and. Okay. And as we said, that's 40 right there because we draw it across right there. So it's 40, over, again, we're still at 150. It comes out to be roughly, we're going to estimate 0.2667. Okay, so let's reflect on what we found so far because this is what we got, right? We have probability of businessmen, probability of approved, and the probability of businessman and approved. But it's looking for or right there. You see that? That or. So that means either. So it includes these two, but it doesn't include this right here. So that's inclusion and exclusion principle. So to do this, I'm going to write down X for our final. So we need P with the businessmen, and we need P with the approved, but we don't need the person to be P, a businessman, and approved. See, we're excluding that, right? We need these two, but we don't need that. Okay, so then we plug in our values. P and the B is right there, so it's 0.4 plus right here 0.5667 minus, remember, because we're not including that one, 0.2667. And that will come out to be 0.7. So that's our answer. So that's the probability that the person is a businessman or approves the hotel being built. It's either or. All right. Perfect. All right. Next, we have to understand what this problem is asking. It's asking for a percentage of the occupation working in the building and trade approve of the hotel being built. Okay, so we have to start off with knowing that of the total building and trade approved, right here, 40 approve and 10 don't. Okay, so that's important. Okay, so to find, because we're looking for percentage, that's different from before. So we're looking for a percentage. We're going to do the total number of approvals, right, from here, which is 40 for the building and trade. So we do 40. And then we're dividing it by the total number of the building and trade people, which is 50. And then we're multiplying it by 100 because, again, it is a percentage. So then we get 0.8 times 100, and that equals I'm just going to write it down as 80%, right? So 80, that's our answer. So 80% of the people working in the building and trade approve of the hotel being built based on these numbers. Okay, the third part is we're looking for, is the attitude towards the hotel development independent of occupation? Is it independent of that? Okay, so we can find with that we need to determine the attitude towards the hotel development is independent of the occupation. We need to check the possibilities equal in the product of the marginal possibilities. And for the two events, which is the occupation and the attitude, which we've already have right here, which we have as attitude and occupation, you need to be independent. The probability of their intersections has to be equal to the product. So it must be, and if they are, equal to the product of their individual probabilities. So the expected and the actual need to be equal. And we got to do that by, that would make them independent, basically. So we have to calculate the probabilities. We already found them above, but we're just going to write them again. Yeah, I'm just going to write them again. And we're going to write PA for approved. We already found that, which was 85 over 150. We actually already found that earlier. And then we didn't do the building and trade. So P, building and trade, BT. And so we have 50 of them over 150. Again, 50, and then over the total, which again, 150. And it comes out to 0.33. And we need to calculate the expected. So we're finding an expected and an independent. And we're going to multiply them. Because this will get, is there a connection between these two? So we have, I'm going to write an E right there. And then we're going to do P, and I'm going to write down independent right there. So to find this, we need to do PA times PBT, right? And that equals, so then we have 5, 6, 7 times 0.33, and comes out to be around I'm writing down the exact answer. Okay. That's what we get right there. Okay, we're just gonna write okay. That was the independent. Okay, now we're gonna find that one was the expected one. Now we're gonna find the actual one, okay? So we're gonna write A over here, and I'm gonna write P dependent. We're gonna do the same thing again. PA times PBT, okay? We're gonna do, but this time, where the actual people approving the hotel, people working there, is actually, it's actually 40. It's not what we thought it was over here. It's not 50, it's actually 40 right here, because this is the actual one. Okay, so we're gonna do 40 for 150 times that's actually just the answer. Sorry, I messed up there. We actually don't need to do it because we know what the expected is. So if that, and since we get this, right, and our actual value of P independence is that 40 over 150. And that actually equals 0.2667. It doesn't equal that. They aren't equal to each other. So the actual probability is different than the expected probability under the independence. So the add towards the hotel development isn't independent of the occupation because they're not equal. Right? They should be equal and they're not. If those two aren't equal, then they're not. So our explanation is the actual, I'm going to document, just write prob, is different from expected prob under so no, and then just go. So there's no independence. Yep, we're just going to document it as end. So there's no independence, okay? That's our reasoning why. Because these don't equal each other, and it's not independent based on occupation. And they don't match. So the added towards the hotel development is non-dependent. And that's all. So we got that. We got 80 for this problem. We got 0.7 or 70% right there. That's how you solve them.